Hey everybody, how's it going? In this video I'm going to talk about how to turn your Raspberry Pi 02W into a Wi-Fi module. The idea is shown in this picture. Let's say we have a computer or a device that cannot connect to the internet because it doesn't have a Wi-Fi. Now we want to connect this device wirelessly to the internet, but for that we are going to use the Raspberry Pi as a Wi-Fi module and then connect it via the USB cable to the computer. So any request or traffic to the router will route through the Raspberry Pi and then goes to the router and as a result to the internet. Is a very niche use case, but it's interesting because throughout this whole journey, let's say, you're going to touch on quite a bit on the networking as well as somehow the information about these sort of use cases are very rare and sparse on the internet. Let's begin. Go to the raspberrypi.com/software, download the Raspberry Pi imager, open it, and then you select the module. It should be Raspberry Pi 02W. Then select the operating system, latest version 64-bit. Insert the microSD card into your computer and then select it here. Put the host name that you can actually remember later on. Fill out the information about the localization. And then the username password, straightforward. Here you have to select the Wi-Fi that you want to connect and then pass the password here as well. Or you can click on the open network to do a discovery here. The next step is very important. I highly recommend you to enable the SSH, but do not use the password-based authentication. For the sake of simplicity in this video, I'm going to stick to the password-based authentication, but you can easily use the key-based authentication. I am going to link a tutorial that I have written a couple of years ago on how to actually do the key-based authentication in the video description. Then whether you want to have the Raspberry Pi connect or no is up to you. Press next and then at the end write. To save some time, I have already done all this step, so I'm going to open the terminal. As you can see, I already connected to my Raspberry Pi 0. I highly recommend you to actually connect it via the cable so things will be done faster. So now what we have to do is to enable the OTG mode. For that, we are going to modify two files under boot directory, namely config.txt and commandline.txt. So this is the path. And for the first one, we have to go to the bottom of the file and add this line, dt overlay equals to dwc2. The next thing is the command line txt. So let me copy the full path here, and you have to go to the root weight here and then type this string. Let me go here, make a space a bit. Vim here now is acting up in the middle of the video, of course, and again I'm not sure why, but let me paste it. So you can see here we have something as root weight modules dash load equals to dwc2 comma g ether. Let me delete this stuff, save the changes. Now we have to enable the IP forwarding. This one can be done via the sysctl command. So just type sudo sysctl-w and then net IPv4 IP forwarding equals to 1. However, this one actually enables the IP forwarding temporarily. If we want to make it persistent, what we can do is to open this file or create the file to be more accurate here under etc sysctl and then 99-IPv or whatever conf file. And then we can actually paste the part of the command exactly we had here, save the changes, and then we have to actually configure NAT USB to Wi-Fi. So what we want here to do is the Raspberry Pi to act as a transparent gateway. So we want to route the packets between the USB interface, which is going to act as a network interface, and it's going to also have its own IP address. We want to have all the traffic or the packets to go through the Wi-Fi and then basically do the translation there for us, right? So for that, we have to install IP tables, because we are going to add 3 rules to our IP tables for this routing shenanigan stuff. So it's going to take a while to basically install it. Yes, save the current configuration. And now what we have to do while this one is installing, in case that you haven't subscribed to the channel, go and subscribe, and don't forget to press the like button. So we have to define 3 rules here. One is going to replace the private source IP address of the USB packets, so the packets that are flowing from the computer, to the Raspberry Pi IP address that is connected to the router. So the network interface would be WLAN 0 IP address. Then afterwards, in the second rule, we are going to permit new connections that is originated from the USB interface. And lastly, we are going to finish the round trip, meaning from the router to the USB. So the first rule to add, as I said, is to do the overwrite. So this is what we see. And then the second one is to accept any packets that is originated from the USB. So we are going to have this one. And the last one is to do the round trip, right? So for a round trip, we can actually have this IP table rule. And lastly, we have to actually make these changes persistent. So let's do that. Now it's saved. And now we have to make a tweak on the network manager. So since the Raspberry Pi USB port is going to act as a network adapter when it's connected to the computer, network manager on the Raspberry Pi, it's going to actually try to manage this. So we want to say, hey, hands off, we are going to manage it ourselves. Otherwise, it's not going to work. So what we have to do, we have to instrument the network manager to not touch anything related to the USB 0. So we are going to make a directory first under etc network manager conf-d. There might be a case that this directory already exists, but doesn't hurt to just run that command. And then we are going to actually create the config file here, USB 0 config, on the same path. And now what we are going to do, we are going to just say, okay, we don't want network manager to manage this one. So you can see unmanaged devices, interface name, USB 0. We are going to save the changes. Now the USB 0 interface is unmanaged, right? We want to delegate the management of this interface instead to the systemd network D. And for that, we have to first enable it. So we are going to enable the network D, and then also we are going to start it. So we started it. Now we have to here instrument the network D to manage the USB 0 NIC. So I did it so quick. So you have to create the file here under etc systemd network USB 0.network, and then paste this chunk of configuration there. So here it says, hey, manage this one, USB 0. do the IP forwarding for us, and the network address would be this one. This is basically the subnet that we want to have. That means our USB 0 interface, when it's connected to the computer, is going to have 192.168.7 and so on IP address, right? So we are going to save the changes. Now we have to assign an IP address automatically to the USB 0. For that, we need to have DHCP. We can install a DHCP server. One of the easiest one to configure, or some people say is the best one, is dnsmasq. So let's install it. And afterwards, we have to create again a bunch of other configurations. But I promise you, this would be the last stage for us. Let's wait for the installation of it. Alright, dnsmasq is installed. Now what we have to do is to create a config file for it as well. So this would be under etc dnsmasq.d/usb.conf. And for that, we are just going to say, alright, assign an IP address to this interface automatically, USB 0, and this would be the range that we defined for it. So now USB 0 is going to have basically this range of the IP address, right? And the lease, of course, is 12 hours. Now we are going to enable again the dnsmasq. First enable, then restart. So I did one thing wrong here, but nonetheless, make sure to enable it and make sure to do also restarts. It's not going to be matter much because we have to restart the Raspberry Pi anyway. So we can now verify whether actually the service is listening or no. This one is the dnsmasq I'm talking about. So you should actually listen to the port 67, and we can see it's actually listening, so everything looks fine. What we are going to do now is to restart the Raspberry Pi. So sudo reboot. So it is going to restart it and should come up in a few seconds. So I'm going to pause the video now, and once it's up, then basically I'm going to continue. Alright, my Raspberry Pi is booted now and I have SSH to it. So here, if you can see at the bottom here, you can see actually my Wi-Fi is disabled, but at the same time you can see there is an Ethernet connection, and this one is a Raspberry Pi Ethernet connection. You can see here Raspberry Pi Ethernet, and the IP address that I got here is the 192.168.732, and then default route is 72. This one is what we actually defined in the network D when we actually created it. And then this is our DNS server. So now if I do IP ADDR here, we can also verify it again here, and we can see, okay, this is the default gateway and so on. So let's do a test. So if I do ping google.com, you can see I get the packet, there's no packet loss, and everything works fine. Just to make your life easier, I have also written another article expressing everything that actually I explained in this video in that article, so you can copy paste the commands easily. That's all for this video. I see you in the next one. Have a great time. Cheers.